Depeche Mode took us to a sea of love with Strange Love. The Cure took us into the sea with Love Cats. The Eurythmics want to dive into your ocean. Susie and the Banshees carried us on sea breezes. But it's Ocean Rain from Echo and the Bunnymen that feels most like AppSec's sad longing for success with the lyrics, "My ship's a sail. Can you hear its tender frame screaming from beneath the waves? Screaming from beneath the waves." Which means this week we talk with Peter Klimek from Imperva about navigating the seas of security and serverless functions, how they can benefit security and how to keep them from hindering it. In the news segment, 25 CWEs float to the top for 2021. Sequoia rides the wave of integer overflows, a sinking feeling for 2FA adoption, clouds on the security horizon, and more. All hands on deck, and stay tuned for Application Security Weekly.
This is Security Weekly, for security professionals, by security professionals. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly. DisruptOps helps you find and fix cloud security issues fast. Getting bombarded with irrelevant alerts is frustrating. DisruptOps gives security and DevOps teams prioritized findings and routes relevant alerts to Slack or Microsoft Teams with automated response options that save you time. Finally, security is inside your workflow instead of in your way. Listeners can access the full platform free for 30 days by visiting securityweekly.com/DisruptOps. In any business today, there comes a moment, the moment you realize you can secure the code as fast as you write it. Instead of testing everything, you can just test the right things. It's not about tools, but intelligent risk management. That's the moment you choose Synopsys. Build secure, high-quality software faster. Visit securityweekly.com/Synopsys. Looking to improve your web application security? Probly is reinventing web application security. Probly focuses on the vulnerabilities that matter, eliminates false positives with evidence-based scanning, and provides a simple point-and-shoot solution that is easy to use. Probly's thorough coverage ensures accurate identification of vulnerabilities in any modern web application or API. Improve your web application security processes by visiting securityweekly.com/Probly and start your free trial today.
This is episode 159, recorded July 26, 2021. I'm your host, Mike Shima, and as always, I'm here with John Kinsella. Hello, John.
Good morning. I'm here to talk about your policy of truth, or you prefer I'll be your professional Jesus. Excuse me, your personal Jesus. Although I have to say, now I think about it, I prefer professional Jesus.
People are people, John. Why should it be that you and I... we do get along great. We get along just as great as Cyber Risk Alliance does with InfraGard, because they have launched the Critical Infrastructure Resilience Benchmark Study. Measure your readiness for ransomware by completing the survey and getting your score. Take the survey at securityweekly.com/CIRB. Do you want to stay in the loop on all things Security Weekly, especially keeping up with all the Depeche Mode lyrics we can get into one episode? Visit securityweekly.com/subscribe to subscribe on your favorite podcast catcher or our YouTube channel. Sign up for our mailing list, join our Discord server, and follow us on our newest live streaming platform, Twitch. Peter Klimek is Director of Technology within the Office of the CTO at Imperva, a market leader in edge, application, and data security. Peter helps global customers protect their applications, data, and websites from security threats through all stages of their digital journey. Prior to Imperva, he held roles at Kaspersky, TransUnion, and Zebra Technologies as a solutions architect, security analyst, and engineer. Hello, Peter. Thank you for joining us, and welcome aboard.
It's an absolute pleasure to be here.
Well, we're glad you're here to, as we hinted at, navigating the seas of serverless functions. And I do just kind of want to start off with one of the things that I think appeals to me most about the serverless concept, or the push towards it, because fundamentally, instead of dropping a whole application into least privileges, we can actually get more granular with the concept of least privileges to specific functions within an application. So this particular function just has read-only access. This particular function has write-only access, and so on. I think serverless helps us get there, but I'm not sure how easy it is to get there. So maybe let's start that journey with a little bit of just what some of the benefits you've seen of serverless, and what are the good aspects of it that you like to point out?
Yeah, so I think the main reasons why we see developers switching over to serverless, there's really a couple big ones, but I'll start with the big one and the really obvious one here. It's really all in the name itself. I think by and large, the vast majority of developers, they just want to write code and run code and not really have to worry about the underlying infrastructure. And we've seen this dream kind of over the years with services like Heroku and some of the PaaS services. And I think serverless and things like AWS Lambda have really become more of just an extension beyond that, where it just gives you the ability to take a single bit of code and then just be able to run it up in production, not have to worry about provisioning or managing the underlying servers or infrastructure. I don't have to worry about patching those underlying servers. And so that gives developers a lot of flexibility and freedom just to really focus on the core aspect of what they're actually writing. Above and beyond that, when you factor in additional things like the fact that it is per millisecond billing and basically gives you the ability to really go and only run code when it's actually, or only pay for code when it's actually running, it's something that's very attractive for a lot of organizations to be able to start switching to.
Yeah, I think you definitely hit it right off the bat there too. With one of the other things is that nowadays, especially with cloud native, DevOps teams are expected to be experts on network, on connectivity, on backups, on IAM policies for that matter, which can get really confusing. But at least in serverless, as you pointed out, they don't have to be as much experts and taking the time out of their day to manage the OS stack. So that's one thing that's taken care of. But as I did kind of allude to, the IAM aspect, it sounds nice, but that's also gets pretty complex. Have you seen that be a stumbling block, or are there more than just the trying to wrap your head around the complexity of IAM policies that can be stumbling block? I can't say that word today for DevOps teams to get into serverless functions.
Yeah, without a doubt. I think anyone that's ever gone and started to work with serverless functions in AWS, and as soon as it starts actually communicating outbound, the first thing that you run into is this, nature of IAM policies, as well as actually some of the more complex networking related aspects of it. I think everyone's first kind of hello world of serverless always runs in kind of AWS's public shared compute environment. You don't really have to worry about those things. But as soon as you start dropping those serverless functions inside of VPC, you have to start worrying about some of the network routing that actually gets set up between those VPC endpoints and actually communicating outbound to AWS services. So you start having set up things like VPC endpoints. And then the IAM policies themselves actually become more complex in that scenario as well, where previously you might have decided that, well, we're initially provisioning and running in the AWS environment. As soon as we move it into a VPC, now we have to worry about things like, do I have IAM permissions to provision and deliver an ENI associated with that instance? And so the permission model starts to get a lot more complex. And after about 20 times in iterations of you trying to start this function and it not working, a lot of times what a lot of developers will just go to do is just say star, and they put that asterisk in there, which is effectively the network equivalent of an any firewall rule. And just to get the thing up and running, but ultimately what we end up finding is that those serverless functions become over-provisioned with entitlements to basically access resources and to manage different other resources within AWS.
Yeah, I think that's one of the dangers is that it can introduce the idea of bringing serverless to encourage good architectures, good behaviors of just focusing on the code that you want to write and run rather than having to focus on the OS or a lot of complex network connectivity. It can have those throwing a star in there. I'm also curious how you've seen. Is there a difference in how you've seen DevOps teams approach serverless? And what I'm coming at from this perspective is building serverless from the start, if you will, just saying here's a type of app that we think would fit well for it, versus the idea of decomposing a lot of these ancient monoliths that have built up over time. And so you're going from one big service into perhaps a sprawl of a lot of different services. I'm just kind of curious if there's a different approach there, different concerns, or sort of like serverless concerns or serverless concerns. And here's a couple things to keep in mind.
There's definitely really big concerns with it when you start actually going and looking at it from both sides. I think for most organizations, they usually start out with maybe just a small independent use case, and they start to develop based on that. And so the nature of serverless functions is that, unlike kind of traditional web applications and some of the other environments, serverless functions tend to be more event-driven in nature. And so oftentimes what you're doing is you're using them to actually respond to different types of events that happen off the network or outside of another AWS service. So, a very simple example is always that a file gets posted or put to an S3 bucket, and I need to go and I need to do something to that. That's probably where we see most people really starting with serverless. They see how easy it is for them to process and to manage that one individual use case and to kind of handle those triggers, and they go a little bit deeper into it. As you go further in that journey, though, I think probably the first thing that people start to realize, though, is by virtue of you decomposing everything and running it into lots of individual functions, it becomes a lot more complex to manage. And one of the most important things around that then is that you have to start looking at frameworks to help you manage that sprawl of all the different code and services. In the early days of serverless, there really wasn't much out there, and people were kind of just running those small functions. But as the complexity started to increase, we started to see the introduction of things like the Serverless framework, which is an open source framework that helps you manage and connect all of those pieces together, as well as we've seen now the introduction of things like the serverless application model and CDK templates and all sorts of other frameworks that are out there to really kind of help with this.
Yeah, I think one of the aspects too is that, especially you're hitting at that complexity, needing to pull in frameworks, is one, it's important to figure out what framework is appropriate for that. And I'm curious too, are there, I don't want to be the type of AppSec person who comes and says, just move everything to serverless and you'll be much better. Sort of, what are some good things that might be appropriate for serverless where it can be really helpful, but other types of applications where you maybe want to pause and say, there's a different approach here, or there's a different framework you'd want to use, and serverless might not actually be what you want, the route you want to go?
Yeah, it really requires, I think, just a careful understanding of what you're actually trying to solve with it. There's a careful balance, I think, between when it's appropriate and correct to choose containers as kind of your primary runtime environment versus actually going down and looking at that serverless route. The serverless route, I think, ultimately, while it does give you that ability to kind of control things at a much smaller level, it isn't necessarily a panel in terms of how it's able to go and solve all problems. It introduces new complexities and new problems that you actually have to deal with. One of them that we pretty frequently realize very quickly is the ephemerality, the nature of these serverless functions, and the fact that they only run for anywhere from milliseconds to in many cases most of them are over within a minute or so, and then they start from their life cycle all over again. And so ultimately with those things you have to now account for, well, how do we go in and how do we actually have the telemetry or make sure that we have the telemetry and everything that we need to actually go in and understand when something does go wrong, do we have the information that's really required to actually be able to go and perform an investigation?
Yeah, and I think that seems like a good point for us, a good detour for us to take, because I suppose one of the reasons this podcast is around, because we haven't yet figured out how to write perfectly secure code. So serverless functions might have insecurities in them. So let's start to pick apart a couple of things that might go wrong. And you were starting to take us down the route of ephemerality investigation, but before we get to that, let's also just talk about, what about different ways of handling security? I was talking about IAM, so identity and access management. But what about secrets? So, for servers to talk to each other, serverless functions may need to talk to data stores, for example, and hopefully they're doing that with some sort of mutual authentication, or at least some credentials. So what does secrets management look like? And especially in the spirit of, oops, there might be a vuln in here and what might be exposed.
Yeah, so from a security perspective, I think there's a couple of main things that have to be really considered. So let's start with secrets management, because I think it's one of the first problems that ends up getting solved or has to be solved across the board. Every developer should know, or I hope every developer should know. Every security professional certainly knows you should never check secrets into code or into your source control. And so by and large, that's always kind of a low-hanging fruit is, well, how do we establish this connection to a database or to other services that we have? There's a couple of different strategies that you can use. I think by and large with serverless functions, where possible, where you can use things like IAM policies to be able to manage and govern that access, you should absolutely do that. because that provides a simple way. You're not exchanging credentials. AWS kind of handles that magic for you underneath the hood. If you're not able to do that, so oftentimes when you're connecting to a database, for instance, you have to use some sort of connection string and username password. In those instances, there's really kind of a progression that we'll see for a lot of organizations. Kind of a better policy than checking it into code is certainly to use things like a configuration file or an environment variable that you're effectively pulling in at build and populating. It's still not a great solution ultimately. I think one of the big challenges that you see with serverless functions is that, and there's a little bit of a misconception of the fact that even though it's serverless and you're not managing server, there's still a server underneath. If you have an OS command, the ability to run an OS command, you can still run an env command and still print out all of the secrets and everything that are displayed there. So it's a challenge of environment variables just as a whole. And the better solution, and really, or I'd say the best solution, and what we really want to see people move towards, is using some sort of secrets management tool to be able to actually govern those secrets as you're connecting out. So AWS Secrets Manager is a great example. HashiCorp Vault is another great example. Using those as a mechanism to be able to basically manage your credentials and then to be able to enforce and perform password rotation. This is ultimately where we want to see organizations get to. And we strongly advocate, before you really go deep into that serverless journey, develop the frameworks and the usage patterns internally from your development teams for how you access and how you provision and build these functions to do that, before you go and basically sprawl out to hundreds of different functions and then have to retrofit them later.
Yeah, and so I think just to highlight really that key point of what you just said too is it's not so much just a shift to serverless, and serverless is going to solve things for us. It's more of, do you have a mature SDLC to support the change, the perhaps even small changes, but the change nonetheless of the design patterns you're going with in serverless. And I think part of that then also brings us back to that aspect of, oops, something went wrong and we need to investigate. And there's that ephemeral part. You can't really quite as easily go through and grab memory dumps, grab running processes. So what does forensics look like? What are some recommendations you have around observability, and it kind of, can it fall into instrument the code? Are there tools that can be running to augment what that serverless function is doing? Help us out a bit with some ideas about making code observable and visible for our devs.
Yeah, this will be the first problem that I think most developers will actually run into pretty quickly. They'll see, initially that everything is really just what they log in their functions, and then they use that logging as kind of their primary mechanism for it. But of course, we all know, we've all been looking at logs for years for developers, and what do they log? They log things that they care about, like business concerns and how well the function's performing. They don't log things like security issues. And so having a common starting point for that is a pretty important part of it. A lot of teams will use observability tools like APM agents, application performance monitoring tools, to be able to understand memory footprint and some of the other things. But it doesn't quite get to that level of really that security detail that we actually need yet. And this is another big part of serverless functions where we see security teams starting to struggle is, well, how do we get the data that's actually useful to us for this? And the good news is there are solutions now that basically are available to us with AWS in particular. I always kind of focus in on that one because it's just the furthest along. But what we strongly advocate for is running effectively a layer that effectively wraps all functions and provides that security telemetry that you actually require in order to basically go back in time and look at, was there anything malicious that was actually passed to this application? And so having those common core runtime layers that are wrapping all individual functions, that gives the security teams the tools and the visibility insight that they actually need to understand what actually happened at any given point in there.
Yeah, I think curious to talk a little bit more about that, because to me, what really stands out of what you're describing is being able to say, here is a request that came in, and tracking that request and response pair across not just the one particular serverless function that might have served it or handled it, but there could be this complex fan out of microservices or serverless functions that handled that. So if you're losing this identity from one to the other of, here was the original request and here was the response that came back, and that response maybe has just an error, or it had indicators of cross-site scripting, SQL injection, RCE, data exfiltration, something like that, that's probably pretty bad. So I'm kind of curious, as you look at logs, are there certain things that you would highlight either as metrics to track or particular capabilities or perhaps use cases that are just really good to keep in mind for these developer teams as they say, well, we know we have this business context of what we want, and we want to be able to debug our own code to figure out what's going wrong. But what else might be out there that we should be perhaps proactively thinking of and enabling logging to do, so that we don't just turn on logs but realize we're unable to answer the questions that we want to ask?
Yeah, so I think you're going to see it from really kind of a couple different perspectives. I think for understanding that basically that hierarchy or basically the chain of all the different functions that get executed or called from one function to another, there's a great project that's part of the Cloud Native Computing Foundation called the Open Telemetry Project. And this really is implementing the concept of distributed tracing. And so it's helping you to understand what's actually happening as that function is calling out to other services. What does the latency look like? What does the various metrics look like? And of course, this is more on the performance monitoring side. But I think from a security team's perspective, the fact that it associates unique trace IDs or spans associated with each individual function, there's a lot of value to be able to start to tie those different pieces together and really understand exactly what happened. Then as we start to get into the actual function itself and looking for, well, what actually is happening here, what we strongly advocate for is to effectively look at it from the perspective of, I want to take really kind of apply a positive security model. And ahead of time, I want to say, this is how I expect my function is going to behave. It's going to be making these network calls. It's going to be making these system calls. And effectively outside of that, I don't want it to actually process or perform anything else. And I want it to trigger some sort of an alert if it does, or even just deny by default effectively in there. And then providing that level of logging information of, this is the exact line of code that did this. This was the request payload that actually managed to trigger this. That gives you really that insight and that understanding of not just how did the function actually go through that chain to actually get to the point, but then also exactly what was the request payload that ended up triggering that and seeing how that actually behaved. And that is really, I think, the best that you can hope for a security model as you start looking at serverless functions, is actually being able to stop it at the point of it actually happening within code.
So let's now broaden to more the ecosystem around perhaps security functions. And we've touched on this a little bit, but I think it's worth coming back to in the sense of forensics. You just gave us a good explanation of that, logging, for example. And you also got into that aspect of the maturity of your organization. And one of the things I'm kind of curious about is, not even maturity, but it's a simple AppSec assertion to say, have an app inventory or just have an asset inventory. Here's all of your running apps. I want to ask at this point, with that mind towards maturity or perhaps even just tooling, how are we managing our broad product or suite of applications? What does this look like from an asset inventory? Does either the cloud in general make this different, or can we say it makes it easier? And how do serverless functions look like? Do you see people treating them as, this is what we call our app, or our app is composed of serverless functions? And here I'm kind of getting not so much the idea of just nomenclature for nomenclature's sake, but just managing where all these are, and the idea of, could we have, unfortunately, shadow serverless out there, functions running that we don't know about that are increasing our attack surface?
Yeah, I'll start with that last bit there, because that kind of that shadowless serverless functions and things that could be really increasing your attack surface. That's probably, I think, the most concerning for a lot of organizations as you really kind of look at it, because AWS provides in-browser editors where you're able to basically go and edit code in line and publish that code immediately up to production, and to be able to start accepting requests coming in off of any individual environment. And so if you want to talk about, shortcutting the SDLC and all of the checks that we've put in place over the years, there's probably no easier way to shortcut it than that, where it's just like literally a web browser and then a couple quick buttons to click and deploy, and then you're pretty much done. And so for organizations, they have to really go and put in the processes and kind of the actual deployment pipelines and the testing processes. Otherwise, you're going to end up with that as a reality, which is a very scary prospect, I think, for all security professionals. In the broader, sorry, go ahead.
Just a quick on that one. That sounds like a good reason by itself to learn how to use Amazon's IEM stuff, right?
Yes.
I don't know if you can hopefully limit down the DUI aspect, but I'd want to kill that one ASAP.
Yes. Yeah, and you can absolutely, there's controls, there's things that you can do to prevent that from happening. But if you don't do that, if you don't know that actually exists as a risk, then I think that's probably something that people are just like, wait, I can just push code immediately and just click a button and that's pretty much it. And developers are like, this is the greatest thing ever. I don't have to go through all these other long, arduous processes. Security can't tell me no when I just click a button. So it's definitely probably high up on that level of risk that you have to think about. But more broadly, as you start thinking about now the actual inventory of all of the other assets that you have in your environment, AWS does make it easier, and all the different cloud service providers, they make it easier for you to at least discover that. They all have robust APIs that give you the ability to understand exactly what your application footprint looks like, easier than anything we ever saw in on-prem networks. So I think that is one of the kind of the benefits of it and how discoverable it is. But the flip side of that is that, the way that I really kind of think about it is really from a code perspective. You've got your inventory of all of your individual functions, but all of those functions are made up of lots of different libraries and dependencies and packages.
Mm-hmm.
And so now when you start thinking about, well, not just what is my inventory of individual functions, but what is my inventory of all the dependencies that are being pulled into that? And I'll go back to, kind of probably one of the most prevalent issues that security professionals remember is the Apache Struts vulnerabilities, where all of a sudden they had to go through and they had to understand, well, where are we vulnerable across our entire environment? Where do we have this dependency pulled into our application because these functions are vulnerable? Now you look at it from a serverless function perspective, and it's gone from just one monolithic application now to hundreds of individual functions that you're having to manage this dependency tree for and understand where you actually might have these vulnerabilities in your environment. So from an SDLC perspective, it becomes, I think, far more complex.
One of the things I'm sort of curious to get your thoughts on, when we started going to, as an industry, heading towards containers, 5-ish years ago, 5-10 years, there was a lot of people going, oh my God, how can we ever keep track of the containers when they're coming up and down so quickly? Mm-hmm. When I was down here, I was trying to track down, there's something I saw in the last few weeks, there's a graphic out there that shows when do you want to use serverless versus a VM versus a container versus these different pieces. But I think what we're seeing is, particularly with serverless, people are realizing they don't have to go all in on a single technology. So more so than in previous lifetimes, for whatever a tech lifetime is, a few years, we're seeing this mixture of 2 or 3 different things. And is that it requires more. The positive I'd put to you is it seems like it requires more diligence upfront when you're actually getting into these technologies. Would that resonate, or do you think it's more people still have a chance to, as they dive in, to sort of come back up and sort of paddle and catch their breath?
Yeah, I think it all depends really. I think on the teams that are really kind of choosing the architectures in the beginning, and I guess how excited they are about the latest conference presentation that they saw that basically was talking about how great the world is just going all into serverless or containers for anything else, and really kind of checking some of that level of excitement that they have and really kind of trying to put in the proper procedures and boundaries around that. I think for a lot of development teams, it's better to dip your toe into the water of serverless, start using it for small individual carve-outs and functions, and then relying on containers really for the rest of the workloads that you're actually running, just because ultimately there's kind of a little bit better of a balance between what we used to do versus what's kind of new here. There's certain types of functions and operations that I think work really, really well with serverless. So in particular, anything that's really event-driven in nature, and so pulling records off a message bus or responding to events, serverless is a great use case for that. Increasingly, we're also seeing it used a lot in batch computing, just by the introduction of things like the AWS step functions, which allow you to actually create some really cool architectures for fan outs and parallelism and complex retry logic, things that was previously fairly difficult for you to individually do. Now you have this ability to really kind of adopt those. And so those use cases we do see come up quite a bit as well in those environments. But more often than not, I think for a lot of organizations, it's really going to be highly, highly dependent on the use case itself.
As you're describing that too, you're talking a lot about the learning steps. Learn about just discovering aspects as you move into serverless. Kind of curious of what have you seen the DevOps teams or just developers in general kind of appreciating about security, and how amenable has it been, or what are some good strategies perhaps for just building more security awareness, security intelligence, security skills within the development team, so that they can be. And I'm avoiding the shift in a particular direction cliche here, but I think what I am getting to is, have you seen it, or how have you seen this a shift to serverless just help raise that security bar for developers, just having developers be responsible for security in a way that's positive and not overwhelming for them?
Yeah, it's maybe not out of choice. I think that a lot of them become responsible for security,
Okay.
but it's more of just because there's really no one else to do it. For development teams that are kind of blazing the trail, and they're going and they want to use these new technologies, but at the same time, security teams are still catching up to all of the other, dozen new advancements in technologies and greatest, other things that have basically come out recently. And so they don't have the time to really go into it in detail. And so a lot of times what we find is that security teams are having to go in and basically deputize the individual product security teams or the actual product teams themselves to start managing and building out the actual model for how do we do this. The best example and where we see this really to be successful is when a organization basically builds a center of excellence really around this. And so it's more of a cross-functional team. We've seen this happen, initially with cloud migrations and building cloud center of excellence. And we saw APIs kind of doing the same thing, where teams would build an API center of excellence that would focus on best practices for developing and releasing APIs. And now serverless is really happening. It's the same thing. So you ultimately build this cross-functional team of your DevOps teams, your developers, your security teams, and everyone basically gets a say in the room, and everyone's able to basically go and share knowledge. And by doing this, you're basically able to at least kind of talk about the higher level security concerns, the things that we all care about and have known about for years, but maybe developers don't think about it in this particular way. They don't think about the way that these functions can be abused, and they're really just kind of focused on really the outcomes that they get with it. And this is probably the easiest way for an organization to get started, other than just hiring someone that's a serverless security expert, which I'll tell you, there's probably about 10 in the field right now that actually exist.
Not going to easily hire out of that problem.
Yeah.
Definitely. Well, yeah, Peter, you've given us an excellent serverless functions of excellence advice here. I wanted to say thank you for that. Any parting words or things that we, what should we be looking forward to in the world of serverless, or thinking about?
Yeah, so the great thing about serverless, I think, now is we've seen really kind of what doesn't work, and are now focusing on kind of that second generation of solutions that can help organizations go and solve these. And so from Imperva's perspective, we basically have just released now a new serverless protection capability. It's actually built off of our runtime application self-protection technology. And we're really excited about this. We've just released it, and it's also free to use until the end of the year. So if you're interested in trying it and understanding how we can help solve these functions or solve these problems, please just hit up Imperva, and we'll be able to get you started with that. And there's lots of other new technologies, I think, that are starting to go and really kind of look at the problem more acutely and solve some of the pain points that we saw originally.
That's fantastic. I want to say, Peter, thanks once again for joining us.
It was an absolute pleasure to be here. Thank you very much.
Appreciate it. And I want to thank John, and want to give a shout out to all the new people coming by our Discord and saying hi. If you'd like to learn more about Imperva, visit securityweekly.com/Imperva. And with that, we're going to take a quick break and return with news of the week.